Hi everyone. My name is Nick. So I'm going to start. I am a backend team lead at OneInch. So today I want to talk about our latest innovation. It's a OneInch Fusion. Maybe you are familiar with Uniswap X right now. So we had it before it was mainstream. And let's start with some small introduction. OneInch actually is one of the leading projects on the market. OneInch was started at Ethereum New York at the same hackathon as we have right now, almost like from Ethereum Global team at 2019 by 2 members. Right now we have several protocols and we have about 2.8 million users, actually a bit more. Right now it's about 3 million users. We have like billions of volume going through us. We are leading DEX aggregator, and not only lead DEX aggregator, we have multiple other protocols. We have Aggregation protocol, limit order protocol, OneInch Fusion protocol, and also we recently released OneInch developer portal for the developers to make it easier to use APIs with no limits and more adjustable limits for them as well. And also we do have a non-custodial wallet on iOS and Android. So let's recap what is OneInch Aggregation protocol is. Basically, OneInch Aggregation protocol allows you to have Uniswap-like experience, but with a bit better rate, because we are trying to aggregate liquidity across multiple DEXs, not only Uniswap, but across DEXs like Curve, Balancer, and about 70 more. Basically, every time you're trying to make a swap, we are trying to split your initial token, source token, like OneInch, for example, in this example, to some small subpaths, and actually try to pick the best pair token, connector token. So like, let's imagine that we have a OneInch token and we need to go to get some DAI token in the end. But we're trying to build a path across wrapped Bitcoin or like wrapped Ethereum, for example, USDC, and only after that we go to the DAI. And the logic of that is because we want to minimize the slippage. We are trying to aggregate all the pools rates across multiple DEXs and find the way where the rate is a bit better. So it's the best strategy if you want to get lower slippage in the market. We have about 220 million volumes during the day. Actually, all the analytics about aggregation protocol and all our protocols is open source. You can check this out on juneanalytics/OneInch, basic.com/OneInch. Basically, yeah, it's quite transparent. Here we have a little smaller volume, but I made this screenshot like at 6 a.m., so it's a bit smaller. How OneInch protocol, aggregation protocol works basically is, as a developer, it's quite easy to integrate that. Basically, you need to fill some data. It's actually for source token, destination token, and the source amount of this token. We have an API for that. Actually, it's a backend algo that calculates the best path, but it's executed on non-custodial smart contract, basically. So it's also verified and audited by about 700 companies. First, you need to make a quote. Basically, you're trying to understand what will be the return amount from source token to destination token. If you are okay with this return amount, you basically call another API handle called swap, and it will return to you the call data that you need to execute with on-chain transaction to the OneInch aggregation router. This is quite simple, and that's how you can integrate OneInch aggregation protocol. Okay, actually, you can also try right now aggregation protocol on developer portal with no limits. It will be pretty adjustable. It's our latest innovation, so latest API aggregation, like latest API for developers. So check this out, please. We also have bounties for that today. Okay, we talked about aggregation protocol. I can say that it's one of the best way to sell something on the market price. If you'll try to compare something to the DEX, like to the DEXs like Binance, it's like it's like market sell for any token. So it's just one atomic transaction with the best potential path, but it's only market sell. But what about limit orders? When you want to specify some target price for any token and you just want to wait until it will be executed. It's a bit more advanced, and we do have a limit order protocol for that allows you to do a lot of fancy things. For example, it's gasless. So for every user, you don't need to pay for gas, because basically you don't do anything on chain except approves of tokens sometimes. Also, it allows you to do additional callbacks. For example, you can use post-interaction methods to withdraw some liquidity from Aave, for example, and only after that execute this limit order from part of the user. It's one of the most optimized protocol on the market. It's open source as well. It's also audited. Right now, it's a part of aggregation router like contract. So let's try to understand how it works as well. So from one point, we have a user. Basically, user do very basic logic. It needs to build, you just need to understand which token you want to swap. You specify the conditions for a swap. For example, I want to sell if 1 Ethereum for 2000 DAI, and like I have some time constraints, for example, for 1 week. And what you need to do, just create this structure and sign it from your private key and send this signed transaction with the structure to Vanish limit order APIs. And that's it. You can do it with our front ends. We implemented basic functions there, so everyone can try that out there. Okay, and on the other part, we have a kind of professional market taker who is trying to fill these transactions. This is the entity who is trying to pay for gas on chain, and actually, this is the entity who can make some profits from that potentially. We also integrate this market taker to our aggregation API as well. So every time somebody is trying to swap something, they can also execute limit orders as well on the aggregation part. Anyone actually can participate in that and be like a resolver, a taker there. But there is an issue that it's you need to understand how it calculates how to calculate the exit price. So you need to take care about the gas price that we'll need to spend to execute the order. Yeah, why I'm talking about that is just to understand how what we are talking right now, that we have a market makers, that's basically the users who create something and send it to to the entities, and the market takers that trying to execute these orders from trying to fill these orders and get some profits, in this case. Usually market takers, it's like developers, it's professional, like some companies that doing that, and makers, it's basically users who have interface for everything. So this is main scheme, how it works. So we have users that signing orders, sending it off chain, and some takers that getting these orders off chain and executing these orders on chain. And there is verification that everything is correct with the signatures and all the rules on chain as well. So it's kind of permissionless. We don't care where you get this order. We only care the structure and the data there. So that's how a limit order works. But there is a small issue that it's not very comfortable for users, because you basically want to sometimes to sell on the market side. But we have a lot of issues right now with me, for example, with attacks like sandwich attacks on multiple blockchains. It's also quite expensive, and it's bad UX sometimes because of the gas prices. So we just questioned ourselves, what if we want to try to solve all of these issues at the same time? What if we want to sell on the market price, but we actually don't care too much that it will be one atomic transaction? We want to have just the best market price during some small time interval, like 5 minutes, for example. And we also don't want to have some issues with MIF attacks for the users, because it's extremely painful to explain them what is that, how to be protected from it. It's quite hard to be natively protected, but we want to make it happen. And also it must be gasless, because it's one of the best experiences that you can get potentially sometimes. So we are trying to build something like that, and actually this is a Vanish Fusion. It's our product that helps you to have the same Uniswap-like experience, our previous experience with aggregation router, but it allows you to have gasless execution, MIF protection by default, and basically in some cases it's almost better prices that we have on the markets, because you have almost limitless liquidity there, because any resolver can accumulate that. Just a small example. For example, if you're trying to swap, this is actually the real life transaction. It's 3,000 Ethereum, craft Ethereum to USDT. So it's actually a Dutch auction that we have at the same at Uniswap X, that allows you to have during some time interval, the price is going down. We're starting from the price that is a bit more expensive than on the market, and we are waiting until somebody will be starting to fill it. The main point here that there is an open market of competitors that are trying to fill it, and the motivation for them to execute this transaction is that when it's going a bit more closer to the market price, they are trying to arbitrage that and get some profits from the arbitrage. And yeah, so basically that's the main point of it. And because of the open competition, not because it's one on-chain transaction, because it can be multiple limit order transactions that will be executed for one order, we have a bit better prices. And yeah, basically that's the main sense of it. We also recently tested that with 11,000 Ethereum as well, and it was also executed better than on market prices with one on-chain transaction. So Vantage Fusion is very useful for large trades. So let's talk a bit about gasless execution. So as I told before, like makers basically do the same as they're doing on limit orders. They're just signing some transactions, some data that is off-chain. You don't need to pay for gas, except you need to make one small approve to one each contract from the token. Usually, most of the tokens support pyramid function, so it's also gasless per approve for the contract. After you did the permit or you made an approve, you just need to sign this transaction, the auction, and set it to the backend, to the limit order storage. And after that, it will be actually shared with the resolvers, with the entities. They will be fighting for your order, trying to fill it, and they will be paying for gas. So as you can see, it's a bit gasless, but it's not gas-free. So actually, every user will need to pay a bit in gas, but not directly with Ethereum, but with the gas rates during the execution of the trade. So like every resolver will be executing this transaction not on the market price, but sometimes a bit below because of the gas price. That's how it works. We don't have any magic that makes everything executed for free. That's like that's the case here. Let's talk about ETH protection. So it's also not that simple because, of course, users don't need to think about that right now because we don't have any on-chain activity from the user side. But we do have on-chain activity on the resolver side, on the market taker side. So every resolver needs, as a professional, we do assume that resolvers on our side, like in Vantage Fusion, are professionals that actually know how to handle MEF attacks. And in this case, they have issue with MEF attacks, but users don't have this issue. So we are trying to focus, trying to allow professionals to solve these issues, not users. And it's pretty simple point about limitless liquidity. Basically, because we have a price auction, it's about 5 minutes. It's pretty customizable. Let's imagine we do have some not very liquid token, for example, some shitcoin, and there are some cases when you want to swap this shitcoin to another coin. If you're trying to do this on some dexes with one atomic transaction, it will be pretty high price slippage because let's imagine it's not enough liquidity on this chain, but there are some liquidity, for example, on another chain. If you have a price auction during 11 minutes of time, some resolver can try to arbitrage this liquidity, to bring this liquidity, for example, from cross-chain and execute this order on better prices that you will have if you'll do a one atomic transaction. This is the main point of auctions, that you can accumulate resources during the price execution. You have enough time for that as a resolver. That's why we have the best possible solution for slippage that is we can imagine right now. So the main picture actually looks like that. Basically, users just need to do two things. Sometimes they need to give a permit or approval to the on each router contract and sign the off-chain order. After that, it goes to a database shared with the resolvers. They are fighting for this order and executed using one each aggregation router as well. Actually, it's quite easy to become a one each resolver. We have a pretty decentralized way how you can make it. One thing that you need to do is just to register as a resolver on the smart contract side, and also you need somebody, maybe some entity to delegate you some unicorn power. Actually, it's staked one each token that will bring you to the top 10 resolvers who will be executing the orders in our system. So if you want to execute orders of market takers, of users of one each, you just need to be on the top 10 of resolvers. If you want to be in top 10, you need somehow to motivate the users to delegate to your pool, and the system works like that. You basically can motivate them by sending some token, right now it's only one each token, to the full factory, and users will have a motivation to delegate the tokens to your factory, and they will get some rewards on that automatically. So it's an open competition who will be on the top 10. That's the main reason why they will that's the main point, so that users will delegate to the only entities that have the maximum APY, and if the APY changing, they will redelegate to other entity. That's why it's always kind of not obligated. They are not forced to send rewards, but they need to compete with each other for that. So that's an opposition how it works right now. There are two options how you can work with Vanish Fusion. Basically, the first one, trying to integrate it into your app, the app, or like any DeFi app that where you need to execute like any swaps. It's quite simple. You just need to have Vanish Fusion SDK. Right now we have it on TypeScript as one of the most popular languages in the market right now. And there is one more option. It's a bit more advanced. I'm not sure it's quite useful for the hackathon, but it's still pretty profitable, as if you want to build some business or doing some market making, it's just become a resolver for Vanish Fusion as well. So if you were interested in becoming a resolver, you can talk to any of our community members here. We have a large booth. So yeah, just talk to us. And also, if you have any questions to Vanish Fusion as to integrate it, you can just ask me later. Right now we're trying to code. This is like, we have a Vanish network documentation here with SDK. I'll try to code a bit. I actually made a small repo with Vanish Fusion 101. You can just scan it. Basically, it's everything. What you need to do is there. I will try to show some live examples right now, like right here. But if you will not have enough time, you can just launch it on your own. Only one thing you need there is JSON RPC endpoint. There is a default one there, but maybe you'll need your own custom endpoint. And one more thing, you need some Ethereum. You need basically a private key there with some Ethereum on it to execute transaction on Ethereum chain or any other chain. Basically, you can switch between networks. So yeah, I'll try to do some live example how it works and just explain how Vanish Fusion 101 works. We'll try to emulate the case as a developer trying to integrate Vanish Fusion to its own app. It's pretty on Node.js right now, but let's imagine you'll try to use a front end like React or something else. I just don't want to focus on that right now, on the user interface part, because we have quite not enough time. So we do have a pretty basic structure here. I will try to make it a bit more visible. 1 second, please. You just need to open index.js file to see the main default picture. Basically, what we have here, we do have a flow where firstly you can potentially make an approve of source token to the Vanish contract that you want to swap. That's the first step. So if I will put through, it will basically just make a ERC20 approve to the Vanish contracts. That's the first step that I just automated. The second part is more interesting part. It's trying to make a quote from using Vanish Order SDK. Basically a quote, what will be the return amount for the source amount of tokens. And the last part is basically do the swap. Creating a fusion order that will be like actually a real transaction. It will be off-chain, but it will spend some resources from your account. And yeah, in the end of all, we're trying to search for all orders that we do have on this address through actually just database. So this is like the main three things that you need to have: checking the approve, doing that approve for the specific token, also quoting some data, and if you are okay with this data, you can execute the swap, and after that you can check the whole history of these orders. This is like basics that you need as a developer to integrate Vanish Fusion. So if you take a look on the config side, I'll it's pretty simple like example. I just put everything here. It's not like production ready code. It's just like some ideas brainstorming. So we do have here some hard-coded tokens. I will try to focus on Ethereum right now. So I just picked network Ethereum here. I have some hard-coded Vanish token amount that I will use for quoting and potentially for swap if we have enough time. And yeah, I have my private key hard-coded as an NV variable. I will not show you my private key, but yeah, you can just put your own later. So let's try to basically run something. I want firstly to run a quote and trying to take a look what will be the return, the return from API of the quote. So for that, I just hard-coded some variables for like Boolean variables to not to do everything at one step. Let's just do only quote. So proof and swap is false and quote is true. Let's run some code. So we do have here basically the quote. It's the first part, and lower we just have a history of all orders on this account. Let's take a look on the basically the return amount, the return amount and the structure that we do have. We do have from Vanish API for the quote. what is important here and how we can like work with that later. So basically, it's just JSON file, and it's quite large, but we don't actually need to focus on everything. Sometimes we need everything, but the main things that we need to see here is basically presets. Presets is actually this hard-coded ways how the auction works. We have price formulas for you, so you don't need to calculate it on your own. It is possible to use a custom price mode on auction, but it's not available on Vantage SDK yet. It will be available quite soon, I think. And the main point why we didn't do this right now is is because it's quite hard to manage the risk in this case. And the custom preset is quite painful, and you can lose some assets there, or it will not work as expected in some case. You need to be sure that you want to specify this the parameters not as default ones for the execution. So in most cases, it just doesn't. You don't need to do this. So let's take a look on the presets, and basically the main point here is that we executed a quote for swapping 100 Vantage tokens to some wrapped Ethereum. And this is like the return amount that I got here. It's calculated in way. Let's try to understand how, what is the real number here. I'll just open Google for that. So this is the amount that we got from the quote, and we can just double check that we have something the same on the front end of Vantage, for example. So let's take a look how the front end works. What will it charge for the same amount of tokens? So we will pick a wrapped Ethereum, and the swap will be from Vantage. So it's 100 Vantage tokens. So the return path is quite the same as we have here. It's like 0.0178. Yeah, it's quite the same, but precision just is different here. We are not showing all the numbers on the UI right now. Okay, so right now let's imagine that we are okay with this trade and we still want to swap some Vantage tokens. Let's try to make an approve. So basically, as a developer, what you need to do is just to understand the 2 token amount from the source token amount. That's actually the price that you will get the destination of the destination token, the amount of that. There are some additional data about that. You can see the prices like from token, that like in USD and 2 token of that, like there is like for pure 1 token actually, and the volume of that in USD as well. And we do have a parameter called recommended preset. It's basically you can just use the recommended preset by default. It's quite often it's a fast preset for the fast swaps. When you have a small amount, it's pretty easy to do fast swaps because the price auction, the longer it takes, the harder the price formula works, and you need to do something with that because the price can go down significantly if it's not a fast preset. So let's try to execute this order, and during the moment when I will be doing that, I will be happy to answer any of your questions. So if you have any questions, just raise your hand. I will be trying to swap at that moment. So yeah, it's quite possible. Right now, it's not possible in the interface, but using our code, the source code that is MIT based on the GitHub, basically you can use smart contract, like not only externally owned account, but smart contract owned account to execute the swaps. It works for aggregation router, it works for fusion, because it's basically what is fusion. It's a fusion of aggregation router as limit order. Basically, you're just creating a limit order. And in limit order, it's quite adjustable protocol, and you can do whatever you want there. You can use externally owned account, non-externally owned account. You can actually not only execute limit orders with ERC20 tokens, but almost with any entity with any token. For example, with NFT tokens. Actually, you can implement what you need to do to make it possible. You just need to implement a transfer function for the limit order. There are several examples in our documentation in our GitHub. I just recommend it to everyone if you want to try limit order aggregation protocol or like a Fusion SDK. You can just also try to take a look on the tests of smart contracts there. There are multiple use cases that sometimes are not public from a user interface, but they are already written, so you can just use them as a starter for your case, for example. It doesn't work like that because the price constantly going down. If you will increase the price, that we will try to make a formula more complex because it will be going down more slower because you have a minimum amount that you will return. So the auction works like you'll never go to zero. It's like between some price intervals. But because of the market, it's kind of predicted how it works. If the price goes too much down during a long amount of time, you will just wait too much and you will not get enough tokens. It can be failed basically. Like when we start an auction, we're trying to understand, okay, what is the market price right now? Let's imagine like 2000 Ethereum. And we are trying to say, okay, the starting point will be a bit more above of the market price. And let's imagine what can happen. What is the minimum return amount that you want to get? What is the lowest rate that you are okay with? For example, it's like 1,950 for Ethereum. So during this interval, you are okay to swap. So we have built a price auction like a function with that is going down to this amount, to this rate. And let's imagine we have 10 minutes. What will happen in this 10 minutes is quite hard to predict. Sometimes the price going down too fast, and if it's below the 1,950 Ethereum, 9,950 like DAI, you'll just get nothing because it will be not profitable for resolvers to execute the transaction. So it's not a fact that it's not a statement. Sometimes it works like that. It just can, if you wait a bit more, it's quite possible that something can go better, but it's not a guarantee that it will happen. So like the interval, the more you wait, doesn't mean that the price will go to your interval, like to your target price. Yeah, so the race will be not definitely better. It can be. It depends on the amount of money that you have. If it's a large amount of money, like for example, it's like $100,000. In this case, it's much more better to wait a bit more because of the volumes. The reason for that is that basically resolvers will need more resources to accumulate, to accumulate to execute this transaction. If it's $100, it's quite easy, but if it's a large sum, they need somehow to arbitrage that, and that's why sometimes when the price the auction time is a bit longer, that's why sometimes the price is better for the large amounts, but it's only works with large amounts mostly, and there is no any guarantee actually. Partial fuels are possible with user mods. So yeah, that's one of the main points for how you can save on gas as a user. Basically, it's off-chain transaction for you and it's on-chain transaction for resolver. But actually, resolver can batch multiple user transactions into one on-chain transactions. So basically, they share the gas price across multiple transactions, a bit more optimized. There are multiple ways how we optimize that. That's why auction is a bit more gas profitable for the users. They are also matching orders sometimes, so it's actually quite efficient. It's like economy of scale. The more users we will have, the better it will be working, and the more cheaper it will be working for the users. Yeah, I just want to comment that we just executed the transaction. So this is we have as a result of executed transaction, and we have actually several orders and the history. Before it was one, right now it's 2 transactions. We'll try to take a look what's happened on this account. If you have any questions, just ping me. So yeah, let me show it again. So basically, yeah, I think I can modify this picture later, but basically here, everything started from here. This part, like the limit orders part, is on-chain part, is actually the light here. All here is on-chain because resolvers field transactions using one each network using limit orders contract basically, and makers, basically users, are trying to make a proof to the limit order contract as well. This activity happens on-chain, and everything else, the matching, the accumulating, and all the calculation, when it's profitable, happens off-chain. Basically, what we do on-chain is we try to minimize the to maximize the efficiency of the contracts, trying to do as minimum as possible on-chain. The minimum you can do is just to verify that verify that rate is okay, and just execute the transaction, just send the funds. That's like the minimum you can do on-chain. Yeah. Okay, I think we can finish. Thank you for everything. Yeah, I will be open there, so for any questions. Thank you.